So, strong acid. Let's say you had, what's your favorite strong acid?
HCl.
Okay, of course. HCl, let's say we had a concentration of 1.0 times 10 to the minus 9. So we're looking for, we know it's dilute, and they don't have to say that word. If we're seeing 10 to the minus 7, 10 to the minus 8, 10 to the minus 9, somewhere in that ballpark, that's considered dilute. Okay, so what you're going to do in that case is you're going to write the general reaction for the self-ionization of water. We're going to do something that looks like ice table. This is just my method of solving it. If you take a look at the text, they don't use this method. I just think the way they did it, which is kind of the normal way, just makes a little less sense. So that's why I do it this way. Alright, so here's what we know. If this is the given concentration, that's the H3O plus concentration, because it is a strong acid, and it does donate 100%. So we're going to put 1.0 times 10 to the minus 9 here.
So when we notice that it's like a dilute strong acid, we automatically do H2O plus H2O, right?
Yeah, this reaction that I wrote, yes, I'll go straight to there. This is more, to be more conservative, this is a solving method as opposed to a true ice table. Okay. So, 0. Okay, just like before, it's like you're starting out with some of this, and we're shifting to the right, just like all of our other problems, plus x, x. And then you go 1.0 times 10 to the minus 9, plus x, x. Okay? Then you say, well, KW is, and this formula will be given on the back of the test. Plug in. 1.0 times 10 to the minus 14 equals 1.0 times 10 to the minus 9, oops, plus x times x. Okay? Solve for x, then take that x, put it right there. That is now your H3O plus concentration at equilibrium, and then you'd say pH negative log of H3O plus. You should get an answer that is very close to 7. Yeah, it could be typically, I mean, I would say probably not lower than 6.85. But since this is really small, it's 100 times smaller than neutral, I'd say it's going to be really, really close to 7. Probably 6.95 or higher. So
Not more than 7?
No, it couldn't be because it's acid.
But if it was a base, it would be more than 7?
Then it would be just above.
Just above 7.
Yeah. So if this was a multiple choice, you just pick the number closest to 7. If it's a long answer sort of problem where you have to show your work, you do have to go through, you will have to use a quadratic formula to solve it, though. There's no way getting around it. Yeah?
And with something like this, you couldn't exclude the plus x, like we did with other ice tables?
No, because if this number was bigger, you could, but now the concentration is just too small. Because at neutral, which this is going to be really close to neutral, this is 10 to the minus 7 comes over here. It's just too close. So it's not going to work out. Is that okay?
Yeah, I noticed sometimes when you write like 1 times 10 to the minus 7 on like the product side. Do we ever do that?
Say that again?
So like there's instances where we'll write for the hydronium concentration 1 times 10 to the minus 7. No?
I don't know. If you find it, you could show me.
Okay.
And then I'll figure out what